All right, so this is the part where like today's session is highly critical. Understanding the data model is as critical as being able to develop it, because without thorough understanding of data model, there always remains some confusion, because there are some gray areas: what to keep where, how is a certain thing being stored, how to retrieve it. There is of course a REST API which makes it quite easy to interact with all the OpenMRS objects and entities, but in-depth understanding of the data model itself, especially the core model, that's also essential. So we are going to go through that now. First of all, first and foremost, OpenMRS itself is patient-centric system. So the primary central core entity is the patient himself, and everything is around the patient. Now, what do I mean by that? So say you have a lab system. A lab system is not built around patients. They're built around the lab itself. So a lab system will say, okay, irrespective of where you deploy me, it could be a clinic, it could be a hospital, it could be a lab itself. The system itself is going to begin at the lab level. So the most important entity in that system is lab itself. Now from that lab, you are going to add more equipment, more test devices, and the workflow of how a lab operates, how a test is conducted, how the results are collected and reported, right? And once that workflow is defined, then then the patients or the diagnosis process comes in place. So such system is lab centric. Similarly, an account system is account centric. So the main entity around which the system is built. For OpenMRS, it is patient.
Sorry, Waze.
Yep.
Are you sharing your screen or just talking?
Oh, sorry. I forgot to share my screen.
Yeah, sorry, thank you.
No, thanks for reminding. Actually, yeah, it's fine. Okay, so I didn't miss much, by the way. It's just, yeah. So OpenMRS's data model itself is patient-centric. So the patient is primary entity in the system, and then everything is around a patient. So all services are for patients. Now you can view data model in three different groups. There is metadata, then there's all the patient related data, and everything else. Now by everything else, I'm going to explain in a bit. What do I mean by that? This is to only help you understand the model better. Otherwise, if you ask anyone, they're gonna say, oh well, there's data and there's metadata, right? But it's important to have this segregation and have it split in three different categories. So metadata is where you have concepts, forms, identifier types, some properties. Metadata is all the data that you set up only once and don't change very often. So for example, if we have defined programs. So there's a DOTS program, there's an MDR-TV program. Now these have been this metadata has been the same for over a decade now. If you want to add another program, say HIV program, then that is going to be a major change. So you will add a new program, add that to metadata, define its workflow, all the rules. You'll add more web pages for it, the reports, everything, right? So the metadata itself doesn't change a lot. Now we are going to talk about all these in detail shortly. Then we have patient data. So in patient data we have the people, the persons. And by the way, in the OpenMRS, the OpenMRS domain, the plural of person is not people, it's persons with an S. Yes, it's bad. It's bad grammar, but right software engineering, you can say. So we have persons and their encounters, patients' observations, patient orders, drug orders or lab orders, and patient program enrollments, patient identifiers, lab results, and everything that's related directly to the patients, right? That's your patient related data. And in the everything else, you have the kind of metadata that falls into the category of metadata, but they are changed more often. So for example, locations, for instance, users. You keep adding more users, change their roles, you keep adding locations, remove them, deactivate them, move them from one hierarchy into another, update their addresses, update their roles. That happens frequently. But these are not related to patient data directly. They are supporting entities without which the system cannot have been built or run, but they are not directly patient data. So these are three different, you can say, entities, the three different groups of entities in the OpenMRS data model. Now before we look into each and every one of those segments, I'll first talk about some general rules of OpenMRS data model. First of all, we study database courses in our undergrad, master's programs and all, and certifications, and we study RDBMSs in detail. So we often see composite keys, right? So a primary key made up of two or more tables, two or more columns is a composite key. In OpenMRS, there are no composite keys. Every table's primary key consists of only one column. That's one of the important distinctions, or you can say key attributes of OpenMRS database, except the bridge tables. So if you are bridging two different tables and there's a supporting third bridge table which only contains two columns, that's where you will have a composite primary key. But other than that, all tables have only one column defined as their primary key. That's first attribute. The next one is the use of UUIDs. Every table, every entity table has this column called UUID. UUIDs are universally identifiable identifiers, IDs, universally unique IDs. So one UUID will not be found in the entire database again, or even any other database again. So that's why they are called universally unique. You can literally assign a different UUID to every particle in the world and will still not come up with any duplicate. That's how unique they are. So every entity in OpenMRS is uniquely identifiable. This is a question may arise that if we already have a primary key, why do we need another unique key? Now the primary keys may repeat for different tables. A primary key with an ID 5 in user table can be repeated in person table and will represent something else. But a UUID will never be repeated throughout the database. That's one of the unique traits of UUIDs. So every entity has a UUID, which means if you do not even know table name, you can pick a UUID. You can scan the entire database for it, and you will get the entity and its table from its relevant table. That's the second property of OpenMRS's data model. These are by the way, these are very important aspects of OpenMRS to understand the underlying system, the core system. Number 3 is that it is auditable, meaning you have a trail of, for every record, for every entity, you have these columns: date created, date changed, created by, and changed by. Whenever you make an entry, whenever any new object is created, this date created is automatically assigned from within the OpenMRS system. Its entire API. This is not alterable. You cannot change the date created once assigned. Then there is created by. Again, the creator once assigned cannot be changed. So the date and the person who was responsible for every row that's recorded. Now, if there are any updates to that row, these two columns come in action. Date changed and changed by, meaning the last update on any particular row, when did that happen? That is your date changed. And who was the user who made that change? That's identified by date and by the column changed by. So changed by and created by, these are OpenMRS's users, and date created, date changed, these are OpenMRS's these are date fields in the database, and they are defined for every table. Right. So this is how you can audit the data, who created each row, and if there was an update, who was the person who updated it. So OpenMRS's entire data model is auditable. Then we have hierarchy. Now it might sound strange. This is a relational database, not a hierarchical database. Then why do we have hierarchy? So it's not completely hierarchical. This is OpenMRS is partially hierarchical, meaning if you have a row and you make a change to that row, that first row will not change, another row will be added, and for the second row we will set a column called parent, and then the parent will reference to the first row. This way you maintain a complete trail of all versions of a particular record. So if, say, a person's mobile number was, say, 1 2 3 4 5 6 7 8, and then that mobile number was updated to 2 3 4 5 3 4 5, then you in the database you will have both these records in place. The first one will not be overridden. The newer value will be shown on the UI, but if you wanted to dig into what was the previous value, you will still get it. So this is not throughout the database. It happens only in a few particular key areas where the hierarchy has to be present. Then the next property is tightly interdependent schema. So all the tables have a very tight interdependency, meaning there are foreign keys all over the place. If you look into the schema, it's you will find foreign key relationships with concept dictionary, with concept tables, with user tables, and we will come to that. We will see this, but it's not like you delete a table and expect nothing's gonna happen. The whole entire OpenMRS system is going to break if you delete a table. So that's something to be kept in mind. You never make any change directly into the database in OpenMRS. So first of all, coming from records perspective, you don't make changes to records that directly unless it's really critical in breaking the rules. And as for the changes in the tables themselves, I mean adding another column or altering data type of one, that is not something you do directly into the database. You use liquid based scripts that take care of such tasks for you. And there's a whole process OpenMS has defined to implement changes into the schema itself. And we will come to that. We will talk about that in the later tomorrow's discussion. Now, next we have soft deletion. What is soft deletion? Soft deletion says you don't delete anything from the database once entered. So if you have created a patient, there is no way to delete that patient from within the OpenMS system. What you can do is you can tell OpenMS that this record is voided or retired. When you void a row, OpenMS assumes that this record is now deleted. This is called self-deletion. A voided record will not be shown anywhere in the database unless you explicitly tell the OpenMS to return the voided results as well. Unless you say that, OpenMS assumes these rows to be deleted entirely. Now, there are two different terminologies being used. One is void and one is retired. Retired is used mainly for metadata tables. Void is used mainly for entity tables. Right? So, if you have voided a patient or a user, the patient is going to be voided, and for the user, the term we'll be using is retired. Now, just like the data is auditable, the voided, the deletions are also audited. So when you remove a record, a particular row from the data, OpenMS records these 3-4 things. So first of all, is the record voided? Who was the user who voided the record? When was this record voided? And what was the reason behind it? Now in OpenMS, if you want to delete, say, a patient, you'll go and say delete patient. OpenMS is going to ask you for the reason. Why are you deleting this patient? You'll say, well, this is a duplicate. When you delete it, OpenMS does not remove the data, that record from tables. It only marks that record as voided. That's a very important point to understand. The OpenMS does not allow deletion. Now, there is a situation I came across in the database while migrating. For some reason, somewhere down the road, one row was deleted in one of the tables. So what happened is that the primary key was in sequence 1, 2, 3, 4, 5, 6, 7, 8, and row 9 was missing. And after 8, the next one was 10. Now, this creates plenty of issues. If you are bulk inserting, relying on the auto increment field, you will not know that one row was removed from the source data, and your latest data is going to create a new record with the primary ID equals to 9, and then from that point onwards, entire data dependency, the integrity will fall, which is why it's critical, it's extremely important to know that even if you are working directly with the database, you never ever delete any row, irrespective of the circumstances. Once a record is entered, it will stay there, which is why there have been multiple requests from the team as well, saying that no, we don't want data from like prior to 2010, 2011, 2012. When we've been consistent, no, the data will stay, we can just hide it, we can void it. And that's the reason behind it. If you delete anything from OpenMRS, you are compromising the entire system. The only way, if you like really truly want to delete old data, if it is required by compliance or by certain government rules, the only data that can happen is if you create a new instance and migrate data from the old instance to the new one. So you'll have a new deployment of OpenMRS and import data from the previous system using the import modules, data import migration modules. Other than that, there's no there's no risk-free way of deleting anything from OpenMRS. That's one of the very key aspects to be explained in about the OpenMRS's data model. Now, there's one more interesting property of OpenMRS's data model, which is that entities are attributable. Now, what exactly do I mean by attributable? I'm going to demonstrate something here. I'm trying to explain what this is. Attributable, it's actually entity attribute type value. Attribute value. This is a design pattern which we study in software engineering courses and design patterns. Now, let's say you have a table, and let's call it facility. Right? This table will contain columns like facility, ID, name, unique code, and then address, district, region, country. These are all your columns in the database. I'm using MS Excel, but this happens on the database level. Let's say you deploy the system with this schema. Now, a requirement comes from the team saying that, well, we need mobile or contact number column as well. What's going to happen is you will go to the code, define, add a new column called contact number. Of course, this cannot be made non-null because you have to take care of all the previous records. Those will be obviously null. So you add a contact number here, right? This means that there will be a change in the database table. There will be change in the Java model itself. There's going to be a change in the service layer where there's going to be a change in the data layer where you're storing. So you're going to set another new value. There's going to be a change in the UI, which will now contain another field called contact number. Now, as soon as you deploy, the very next week, say another request comes. Well, we have contact number and we have another secondary contact number field. Add that, please. You will have to go through the same cycle again, right? So for every change in the table schema, if you wanted to add something, add a new column, you will have to go through a whole cycle of redeployment, changing the code, changing the tables, stopping the server, deploying, and then restarting the server. That's how that change is going to take place. OpenMRS has adopted to something called attributable design pattern. What this design pattern says is this: instead of making these vertical changes, you make horizontal changes. Meaning, you have a facility, you add two more tables. One table is facility attribute type, and the other one is facility attribute. The first time your team requests you to add contact number, you make no change to this table. This table remains as it is. Instead, what you do is, in this table is like this: attribute type ID name data type. Say it's like this. In this table, you add records. You don't add anything to the schema. You only add new rows, and the name you say contact number. Data type is string. Once you define this, in your code you make it dynamic, such that once you have set these fields, you are also setting the attribute types. So facility attribute is going to contain what? Let's say you have a facility one, its name is Dushanbe Polyclinic. Let's say this is and it has a unique ID DP01. Address is Dushanbe, or it's some district XYZ and Rajasthan, right? This is your facility. Now you are to enter its contact number. What you're going to do is you're going to go into facility attribute and facility ID, attribute type ID, attribute value. Now what's gonna happen is, for facility 1 you have attribute type 1, and then you are entering a contact number. Now let's say the team demands another change. The team says, well, we need a secondary contact number as well. You are not going to make any change to the database. You're not going to make any change to the service layer, to the data layer, the module. You don't restart OpenMRS, you do nothing. All you do is you add another attribute here, say secondary contact. This is also going to be a string, and in this table for the facility 1 you are adding secondary contact. See, I didn't make any change to the database tables now. In this case, I'm only adding more rows. I'm not adding any column. So this way, for the facility entity, I'm defining custom attribute types, and for those custom attribute types I am defining values for every entity. So for every facility, every attribute type of that facility, I am defining the data here. So these are actually acting as customized columns for the facility table. This is a design pattern OpenMRS heavily uses, and you will see that as we explore the schema further. And it's one of the main strengths of OpenMRS's data model as well, that you define a core model and you don't need to change the model for every kind of change. Now, having said that, of course there are certain changes which demand making alterations in the database, and there are instances of such, but those instances will be very rare. You don't make changes in the database's schema every time something changes in the field or a new requirement comes in. So these are seven distinctions, seven rules OpenMRS implements for their data model. Now this picture you see here, it's just to give you a sense of what the OpenMRS's database actually looks like. You can explore this schema in OpenMRS's wiki, on OpenMRS wiki. Actually, let me show you. It's already there. You can explore it yourself. This is OpenMRS wiki, by the way, openmrs.atlassian.net/wiki. You're gonna find all sorts of resources over here. Let's go to the model itself. You will see, and by the way, this is only OpenMRS core. This is core model. This is not the complete thing. So for patient, these are all patient related tables. These are all person related tables. We have concept related tables. We will discuss all of these in detail right away. So let's now talk about individual segments of OpenMRS schema. The first one is user. Now user is an entity which is you can say is independent of other tables. So user is the first thing that gets entered into OpenMRS as you install it. There's one default user called admin, and from that point onwards entire database can be blank, but this single user table cannot be blank, right? So this is you're defining your startup, you can say, entity. So first you have to have a user in your data. Now you will see a relationship between user table and person table. By the way, this is plural, users. You will notice all other tables as singular. Role, privilege, it's not privileges, it's not roles, these are not plural, except user. The reason being, is because user, the word user itself is reserved keyword in MySQL database and all other databases as well. So when you say user, the SQL query itself confuses it. Is it a table or a what? So you have to put in quotation marks to say no, this is a table. So to avoid that situation, OpenMRS kept this table as users in plural. But anyway, you will see that users has a relationship with person. This is non-identifying relationship, meaning it is nullable. You don't need a person record to be able to enter a user, right? So that's something to be noted. It's important. Now a user can have more than one roles. So this is one to many to one relationship between these two tables. One user can have multiple roles. So same user who is say a receptionist can also have a role of radiologist, in the OpenMRS system. Generally we tend to have users who only have one single role, but OpenMRS makes it flexible to have multiple roles for each user. Now these roles, every role has privileges. So you have a user role, and for every role you have privileges. Privileges are there's a whole list of operations that are permitted for a particular role, right? So what this user can do, who is this user authorized, what is this user authorized to do in the system is defined by what privileges he has, and more specifically what privileges his role has. Now, privileges are like such. You may have a privilege called view patient. You can say, okay, anyone in any user in our database can have view privilege, but if it comes to changing anything in the patient record, that privilege is only available for, say, clinicians. Or if you want to delete or void a particular patient, that is only available for the admins. So this is how OpenMRS works with privileges. So there's a whole lengthy list of privileges, all the operations that can be done within a system, and for all those privileges you define roles and enable switch on switch off those privileges, and users then inherit those permissions. So these are like permissions. Again, users table itself is attributable, so you have user properties. Now, users table itself, it's not that extensive. You can extend the columns using user property table. Now let me show you what this table looks like. OpenMRS users. Now this is users table. Let's go through all the columns. You have user ID. This is primary key. This is auto increment. You can define it, self-defined. Then there's a system ID. System ID is a string. You might be importing this record from somewhere else. You may have a manual system running in a clinic, in a hospital, with unique system user IDs. So this ID can be used for that. You can call it as like employee code. Then you have username. The username is what the user uses to log into the system. So my username is ows.hossein, right? So you will all be assigned, whenever you work on your own unique usernames. Then we have password. This is encrypted. This is not open text. Password is encrypted, strengthened using password salt. We have secret question and secret answer. This column, I think, yeah. Secret question is its answer. This is used to recover your account. And then from this point onwards, you'll see all these audit fields: creator, date created, changed by, date changed, person. And since this is not entity data, not patient data, you will see retired, right? Retired by, retired reason. Then you have UUID. Now these two were newly added: activation key, email. When you create a new account, you define an email address, and on that email address you receive an activation key, and you activate your account from within that key. This is a standard way Gmail and new email accounts are created. This is a recent enhancement OpenMRS has made to the user's entity. These two columns did not exist in the earlier versions, right? Now you can see the user table itself doesn't contain a lot of columns to enter anything. Now you can say, well, user, what do we need? User may have certain roles. Yes, there's a user roles. This is a bridge table. There's user ID and there's role. And this is a composite key, by the way. This is a composite key because it's a bridge table. Okay, so you have user roles. What about role itself. Role, you have a role description, a UUID, and these are the roles which currently exist in our system, right? So we have auditor. Auditor basically is someone who has view access, read access to the entire system. Auditor cannot make any changes, but he can read anything from within that system. So if you have someone who's evaluating your database, you will create a user account with only auditor permission. Authenticated means the user is able to log in, right? I mean, which user won't be able to log in and interact, that's also subjective, because sometimes you create special user accounts only to integrate two systems. For that you may not even have an authenticated there. Then there's data entry. These users are this role is assigned to users who are only responsible for entering data, right? They are not going to be changing anything, they can't void or delete anything, they are just going to enter new, you can say, form, filling the forms. Then we have lab supervisor, lab technician, and then lab view. These three roles were created for the lab system. Specifically, supervisor can obviously edit and also delete data, and the technician is basically responsible for entering data, lab data. So they are not directly related to anything other than the lab data. They cannot change the patient programs, they cannot make any changes to their regimens or drugs, whatever. They are only limited to handling the lab data. And the lab view is the person who is only going to view the lab data. Provider we are going to talk about in a while. Then there's system developer. This person is the developer of OpenMR system. A system developer has access to everything in OpenMRS. So you will never assign a system developer role to an ordinary user. That is something to bear in mind. There should be, we recommend that there is only one system developer from the implementation side, so that we have exactly one person who can make critical changes to the system. Everything else should be done through users having these custom roles. Then these are two more: MDR, TB, says TB specialist, and the treatment supporter role. And this is right now it's not in English. We have to look into that as well. It does create certain problems. We can provide translations using other means, but this is a fix that needs to be made in the system.
Maybe you need to change the screen resolution.
No, it's basically it's like this.
Yeah. Yeah. Now
Sorry,
good.
I don't have a high quality mic right now, so I'm presenting on Mac, that's why. So yeah, so these are all the roles within the system that exist within the system. You will have these descriptions, and they basically tell you what this role is about. But it's a problem. These all have to be in English, by the way. Their translations can be provided in another form. That's actually a data problem. We need to fix this. Okay, so I explained users, user role, and role. Now if you have anything other than what's defined in the columns, you use user property for it, right? Again, the same concept as attributable. Now these are your user properties. So for example, default locale, every user can define his default language or default locale. So for the admin, the default one is English. For uh, any other user. These are all user controlled ones. So user can define his own locale. Then where this user is logging in from, this is optional. We can record it, we may skip recording it. Again, our login currently does not ask for the location. It asks for username and password. But if say you have to add another field, another drop down which lets you select the location from where you're logging in, then you will be using this default location property. And we then have login attempts. How many failed login attempts existed? Because after certain attempts, your account, OpenMRS will lock your account if you have say 7 false attempts to log in, right? And then these are again plenty of other properties. You can put in any other property you want. This is again customizable, not OpenMRS's enforced ones. So these properties come as you configure their data. They are not there by default everywhere. Anyway, so moving on. So this is how OpenMRS handles users. So we have users, we have their roles, we have their privileges. Now there is another link to person table. I am going to come to that. What does person table have to do with user? You will see that the user table does not contain any personal information like name, gender, date of birth, right? So where do those get stored? That's where person table comes in. Now in OpenMRS world, every human is going to be in the person table, be it a patient, be it a user, be it a healthcare provider, be it a clinician, whoever. So all of those are going to end up in the person table, and person table itself is also independent. It does have a loose dependency on concept table only for one particular column. Other than that, person table is independent. And again, this link, this foreign key relationship is non-identifying. You can have it null as well. So yeah. Now something to remember: person, again the plural is persons, not people. And anyone is in the system, any human is a person. You can see that there's a person table, and then there's a person name table, there's a person address table. That looks like something strange. Why do we have a whole table just to store person name? And within that table you will see there's a given name, there's a family name, there's a middle name, there's a surname. There are many columns for just to capture the name itself. The question is, why do we have a table instead of columns inside the person table? OpenMRS is very dynamic in a sense that it is an international system, right? And it is not uncommon in some countries for people to change their names. So say let's say for example, if say someone is a Jew, right, and he later reverts to Islam, becomes Muslim, the name's gonna change, right? Now if you are changing the name, meaning previous name is going to be overridden. OpenMRS says we have to keep trail of that. So if someone was identified by Peter and today they are identified by Ali, then Peter should also be remembered by the system. Because it's a name, previous forms, past data will have those references which currently will not be identified because the name has changed. So this is why there's a person table and then there's a person name table. In like generally you only have one record for person name, but there are instances where you have multiple records in person name, which is why there is also a field called preferred. Which one is the preferred record for person name? So we are not talking about person's name. Do you prefer the first name or the last name? It's the whole record. Which record is preferred against a person? So which is why we have a person table and a person name table. Now from person name table we can also guess what person address table would be doing. Now it's easy to understand because when we say person address, of course addresses do tend to change a lot, and this is very important because so we've done a bunch of programs in Africa. It's very common in Africa, especially rural African regions, for people to migrate. They keep migrating from one place to another, and there's no fixed address. Now a person might be in one region, in one district, and may shift to another one while continuing the treatment, and then another. So how do you keep track of all the addresses? How do you tell who was providing the treatment support when the treatment started, who is providing it now? So to keep all those trails, to trace back everything, person addresses are also stored as like a whole history, instead of just one plain address, city, state, whatever. Then we have, so here a person can have multiple name records and multiple address records. Person is also entity that is attributable. So we have person attribute type and then person attribute. So for everything which is not supported, which is not provided in the existing columns, you can create a new attribute type and then provide its value. That's very easily to do in OpenMRS. Let me actually go ahead and show you how it looks in the database. So you have this person table. The person, you have gender, birth rate estimated, meaning is this date accurate or it's just you entered a year and the rest is just estimated. So that's the field that's telling you. Is the person dead? If death has occurred, what's the date? And cause of death. Cause of death is a concept, and we will come to concept in detail shortly. If the cause of death is not within the list of reasons in our system, then there's an open text field you can enter here as well, right? But other than that, there's nothing there in the person table. Where you get the name from, it's this table, person name. Now you can see person name as prefix. You can be doctor, you can be lieutenant, you can be engineer, whatever the prefix is. Then there's given name, which is your first name, middle name, and family name prefix, family name 2, family name suffix. That's just to enter a person's name. Now this might looks like very comprehensive, but let me tell you, this is still isn't enough. Especially in our region, the Indo-Pak, the names tend to vary a lot. So in India especially, you have names, very lengthy names. So one name might be look like a whole sentence, and you have to fit all of those fields over here. And now similarly, say an example from Indonesia. So we used to have a funny story. There was this doctor who came to Pakistan. We worked with them in Indonesian program, and her name was Firza. The name was Firza Ansli Putri. That was the name. And we entered a name like, okay, Firza is given name, Ansli is middle name, and Putri is maybe family name. And when she came to know, she laughed. Said, no, it's not like that. It's just one first name. It's just first part of my name, Firza Ansli Putri, which literally means Firza, daughter of Ansli. So that's just one field. Meaning it really varies how you represent your name, which is why OpenMRS has kept so many columns here to adopt in your own fashion. But anyway, we too much about the names. Thankfully, in Tajikistan, it's quite simple. First we are using a given name and family name. These are the two fields we are using for the most part in the system, right? Now, after person name, you also have person address. Now, looking at address, again you have a whole range of fields to represent address. So you have address 1, address 2, and these are standard fields. So city or village, that's pretty much standard across the world. You either live in a city or in a village. Your hierarchy might be like a state in a presidential system like US, or in other systems you may have provinces. So state or province. Postal code, that's standard across the world. Country name, and these are your GPS coordinates like latitude and longitude. Other than that, there's one more thing: county or district. So within states you have counties, within provinces you have districts. So these are the standard ones. Other than that, any country may have like any kind of hierarchy. So for that, OpenMRS leaves you at just 1, 2, 3, 4, 5, 6, all the way to 15. So you have 15 different fields to define any type of hierarchy you want to define. And that's actually a lot. We don't need more than like address 1, address 2, address 3. More than that, it's generally this is sufficient for many programs. But OpenMRS has added support for plenty of these columns. Now, the data itself, each person may have multiple records. So that's something to keep in mind. The preferred, this tells if this is the active record or not. So if I say, if I limit to person 2, I'll have to hunt. Okay, so here we have a record. Person ID is 25. There are 2 addresses. One is maybe an old one. The other one is most recent one, which is preferred address, right? And you can say in the trail as well, the first address was written in 2011, then it was changed in 2013. But the preferred one is still the first one. So that's how we look into the address fields. Alright, coming back to person, there are person attributes as well. Now have a look over here. In person attributes, what we are storing is person's race. I don't think this is being used anymore. Birthplace, citizenship, mother's name, civil status, health district, health center, and who was the volunteer. These are custom fields which were supposed to be columns, but since we are making use of OpenMRS's attributable property and defining rows against all of these variables, and for these variables the data is going to be kept in person attribute table. So for every attribute type we have a particular value, right? So that's how person entity is made attributable in OpenMRS. Then we have person relationships. Now relationships are used to define how two people are related in the system. So one person can be a patient, another can be that patient's child. So say there are two patients or both are siblings. To define that these two are related, you can define a relationship which goes into a relationship table, and relationship has a relationship type. Now person A is related to person B in what manner? So person A is, say, if you say relationship person A comma person B, means A is the father of B. So if you have A, you have B, and relationship is father, then A is father of B. That's how you read the relationships, and I'll just show you what relationships exist in our system. So we have doctor, the relationship is doctor patient, sibling, parent child, uncle, aunt, or niece or nephew. So these are that's how we are defining relationships. You can say that these are somewhat generic, as in we have doctor to patient, this is gender neutral term, sibling, parent child, these are gender neutral terms. This is where gender is defined, but so we have entered a slash and using just one record. Otherwise we'll have to introduce, say, 50 other fields. So you might add new relationships and define as such, but so far this is sufficient for our system. Okay, now moving on. This is all about the person entity in the system and its related tables. Then we have locations. Just like person location, again locations are not stored in one flat table, right? Location table has a whole hierarchy to it, and as I mentioned earlier as well, we are using an OpenMRS module called address hierarchy to define the hierarchy of locations. Location could be a facility, it could be a hospital, it could be a household, a treatment center, it could even be an ambulance. That can also be a location. OpenMRS is quite liberal in that sense. You can use locations in any manner. It's just to define certain geographical entity, right? Now we are using address hierarchy, and address hierarchy has two tables. One is where we define the levels. Right now the levels we have are like this. So we have on top we have level country, then we have second level which is the state or province, then our third level we have district or county, then we have another level of region, and we also have sub-regions now. Now you might ask, what's the difference between these and the columns in the location table itself? Let me show you the table first. You might ask, the location table already has city, state, country. If we already have these in the location table, why do we need another table to define the hierarchy? That is because in this table there is no way to tell which one is parent and which one is child, which one is on top in the hierarchy and which one is below. So country, we know country is top in the hierarchy. This table has no way of telling that country is top in the hierarchy. This table does not tell us that cities are part of provinces. It's not telling provinces are part of countries. It's just a flat hierarchy. It's just, there's no hierarchy. This is a flat table. To represent a hierarchy, we make use of address hierarchy level. That's the table which defines us the let me actually go to I don't really have, I think, the whole data over here. Let's just explore the test instance. No, it's on my the system. I'll just verbally tell you the kind of the hierarchy we have is in the address hierarchy. On top we have country, then state, province, then district, and then region, then sub-region. That's the hierarchy we are defining. So when you select a location in the UI, you must have noticed you also select in the same hierarchy. We need these tables, this module, to be able to do that. Now, apart from this, the location table itself doesn't contain, again, a lot of information. These are just address fields and name and description, that's it. What about the rest of the details? Again, location table is also attributable. You have attribute types and you have attributes. So attribute type has one field called level. This is what tells you the level of this location in the hierarchy. Is this location a region? Is this location a district? Is this location a facility? So you'll see that Dushanbe itself is a location entry in location table. We have Khatlon, we have Kolob, we have different regions and sub-regions and districts within the system, and I'll just show you the whole hierarchy in a bit. But this is the location attribute. These are two attribute types, and then there's a site code. This was a unique requirement from the LIMS, the system we were integrating it with. We have custom site codes, we have to be able to record them. So we added a attribute type to support that. And then again, for these attribute types, we have their values in the location attribute table. You can see value reference, region, sub-region, district, facility. These are the levels, right? Now, let me go ahead and show you, but before I show you, I'm going to also talk about location tags. Now, so tags are basically to give you tags are a handy tool for a convenience for custom business logic binding. What do I mean by that? So for example, you are saying, well, I should be able to define locations based on the services provided inside them. Let me go ahead and show you actually on the UI what I mean by that. This is the OpenMRS interface. I'm going to go into locations, and then we have these so-called location tags. So for one location we have defined certain tags. Now you can see location name, description, pretty much everything is blank at this point for this record, but just wanted to show you this use of tags. So by tags we are defining, okay, is this a DOTS facility? Is this a facility providing lab services? Is this a lab which also does culture tests? Not every lab does, right? So these are different tags you can define to sort of filter and sort certain locations. And there's no hard and fast rule on how you use location tags. These are literally like hashtags in any social media. So you can assign hashtags to your locations. Just think of it like that. And we haven't yet defined location tags for all our data, the facilities. This was something that was, I think, required in the previous wave, but this information was not provided. So Anwar, if you can also take note and kind of provide me all the complete information of every location, especially these tags, I might add them in bulk in the database. So anyway, moving on, these are our locations. Now, after we've discussed locations, let's now talk about the patient table, the patient entity. Of course, this is a patient-centric system, so there should be plenty of tables for patients, right? I would say right and wrong. There aren't actually many tables for patients per se. We have a patient table, yes. We have a patient identifier table where we keep patient identifiers. We have allergy tables, and we have conditions table. The rest is defined in some other format which we will come to. Now, patient to person foreign key relationship is identifying, it's binding. So you have to have a person record to be able to enter a patient, and this is one-to-one relationship, right? When it comes to patient identifier type, what is patient identifier exactly? Patient identifier can be thought of as an MR number. But think about this. In some countries, hospitals may have their own MR number. Then the national system, the national program will also be assigning another MR number. So you have a hospital's MR number, and then there's a health systems, the government's provided MR number. Then you might also be using national identity or citizen citizen number as a patient identifier in some countries. So now you have a situation where you have multiple identifiers, multiple ways to identify a patient, which is why again OpenMR splits this system of identification into multiple tables as well. So you define identifier type, and in identifier type you also define two particular fields, whether this identifier is required or not, is this compulsory to create a patient, and what's the format going to be. The format tells how to validate the patient ID so that you don't make a false entry, an incorrect entry. OpenMRS has a very good support as it comes to patient identifiers, and let me show you something here. See, you have these 4 identifier types in our system. So we have in OpenMRS's own unique number which OpenMRS generates. You don't need to care about this one. There's a suspect ID. Now, what is suspect ID used for? In our flow, the whole TB program flow, the first point of entry for susceptible TB programs, especially outreach programs, is suspect ID, because initially a person is not confirmed as a TB case, they are presumptive cases. Then when they get enrolled into a DOTS program, they are assigned a new DOTS ID. If they are enrolled into MDR-TB program, they are assigned an MDR-TB ID. And if you go into any identifier, you will see that there is a regex format. Regex is regular expression. How do you validate that the value entered against this field is valid? You also define a rule for that validation over here. You can define that, right? Is it required or not? Location behavior, is this identity specific to certain location? If that's so, you have to also tell where this ID was generated. So going back, I don't know if we have done this. Yeah, we haven't used these, but you can say that if you are assigning an MDR-TB ID, then you also have to tell the location where this was registered, and you also have to say to be able to you also can say that this ID is unique throughout the system, meaning the identifier cannot be repeated, or this identity cannot be repeated within the same location. It can be repeated for other locations as well, right? And then there is another identifier validation field. There is, for example, a Leun check digit validator, which says that this basically validator saves you from accidental entries. How? Let me give you an example here. The scenic trait is quite important to understand, because these are the requirements which may arise anytime, like based on how actively the system is being used. Say you have an ID which requires to be 7th character long, alphanumeric only, right? Or you can say, yeah, so you can say, well, if I am entering an ID ABC1234, this is valid. You can say if I'm entering an ID 0988764, this is again a valid ID. It's 7 characters and an alphanumeric. But if you are saying ABC underscore 988, although this is 7 characters, it has a special character, it will be invalid, right? Again, if I enter an ID like this is also going to be invalid. This is the easy part. But what if while entering this ID, instead of writing or just say 11223334, this was the ID, and by mistake you wrote 11222234. Now it is 7 character long, it is alphanumeric as well. How do you prevent false entry over here? That's where the check digits come in place. So you have a check digit, say Leun check digit, and results in 6. This number 6 comes from a formula which is calculated based on all these numbers. So if a user is entering this ID and writes 6, this 6 will not match. The check digit will fail. It will say, no, something is wrong over here. You have changed something, because I am calculating the check digit and it's not 6, it's coming out to be 5. This is where that check digit saves your life. And we have recommended in the past as well to use check digits in your system, so you have very fewer issues, data entry issues, especially when it comes to identifier, because you see, once an identifier is assigned to a patient, it's extremely difficult to change it. And if you assign it incorrectly and say the tests are performed, the sample went away, the results came in, the treatment started, whatever, and then you find out, well, this ID is not the same as we gave it, it has a mistake. Now you have to live with it or enter all the data from scratch. So which is why we've been recommending to use check digits. But anyway, that's program team's decision. I wanted to just give you an in-depth overview of how patient identifiers are being used. So we have 4 identifiers in our system, the MDR-TB program, and actively we use dots and MDR IDs. Now, you can search for a patient using any of these IDs. You can search for a patient using his name. You can search based on certain attribute type. Actually, let me also show you that. This is a patient identifier type, and you will be so this is person attribute types. These are person attribute types. Say you want to be able to search for a patient based on their health facility, health district. You can just enable this check, and now the OpenMRS is going to use this field to search for the patients too. But mind you, this is a sensitive operation. It may slow down significantly. So for example, if you make birthplace as searchable, now you know if you enter Dushanbe, you will have hundreds of thousands of records. So that's not really a very effective way to search for a patient. Yes, you may add another field called mobile number. Now this one you can make searchable. So tomorrow, if you want to be able to search for patients via their phone numbers, you're going to add another person attribute type, phone number, make it searchable, and enter mobile numbers over there. That's how you can make patients searchable through their attribute types. So just like patient identifiers, you also have person attributes that can also help in searching. Now there are certain tables which we are not utilizing because these didn't exist previously. We are not making use of allergy and allergy reactions or conditions for patients. This is a modern admission in the system. You may record patient allergies exclusively. So if say a patient is allergic to lactose, you may record that. And if the patient does consume lactose, how does it respond to the what's the reaction on the body? So you may have say skin rashes. The allergy is going to be lactose intolerance, and the reaction is going to be skin rashes. That's how we define allergies. We are not yet utilizing them, but again, when you make certain enhancement in the system, especially for MDR-TB, these are very handy. Whenever you make certain changes, these may come very handy. And then certain conditions, what are the clinical conditions a patient may have? These are what exist, but we are not currently utilizing. For the patients then, in case you're wondering, what about the entire treatment and diagnosis and screening and closing the case. What about that? So those are going to be handled in patient programs, and they have their own dedicated workflows, and we will talk about them in detail after 2 or 3 more slides, because our entire DOTS program and MDR-TB program depends on them. So this was for now about the patient entity and its respective tables. We will resume back to what's more in the for the patients. Let's now jump to orders. Now, order is literally what the word means. Orders are services which clinicians ask for to provide patient care, right? There are right now 2 order types in our system. Actually, in the whole OpenMRS system, there are 2 order types. There's a drug order and there's a lab order. Drug order is when a clinician asks something from the pharmacy, and lab order is when the clinician or or your specialist from the lab, right? What other order types might be? You may say add something like bed, hospital bed. So you may order a bed. A doctor may order for a bed, but that's custom. That's very unique. This may be a unique situation which only a few healthcare systems may adopt. In general, there are 2 globally accepted, widely used order types that are drug orders and lab orders. Again, if you look closely, the word order itself is again plural. It's orders, not order. Why? Once again, because in MySQL and many other relational databases, the word order is a reserved keyword. A reserved keyword, whenever you use it in a query, the query fails when you are writing a query. So which is why OpenMRS chose to keep this table name as also a plural. That's the only reason. Now you'll see there's an orders table, and order has order type. There are only 2 order types, drug and lab. Then there's care setting. For care setting, again, there are two values only: inpatient and outpatient. Inpatients, all the patients that are being treated within the hospital, within the facility, and all the outpatients are the walk-ins, the ones who are getting their treatments but not hospitalized inside the facility. There are no more than these are the only 2 care settings we have, and if a certain program requires more, you can add more care settings. So for example, if your patient is you are neither admitted into the hospital nor given care at your home, but say there is an ambulance, there's a mobile health unit where the patients receive their care, you can add another 3rd record for that as well. But this will happen when you have outreach programs, not right now. Then after the care settings, we have a drug table. Whenever you are ordering any medication, this is the table that comes in place. So you have name of every drug identified by their formula name, by the way, not the marketing names, and their strength, their dose. These are the few fields defined against a drug, right? Then there are 5 or 6 more tables which are recent additions that we are not currently using. There is an order frequency. So for example, if a doctor has ordered certain test It's easy. Well, order type is lab order, and the test is called smear microscopy. But if a doctor says no, this test has to be repeated every month, there's going to be a test every month, that's where you use order frequency table. Otherwise, you don't need it. Similarly, OpenMRS has split out drug order table from orders. Similarly, just like lab orders, we have split out from the orders in our lab system. We'll come to that. So that's where you can say, okay, OpenMRS has modified this. It didn't exist previously in the current schema. This has added. We are not currently using it, but we can. Like orders, it's good to have drug orders and lab orders in separate tables. Similarly, drug ingredient. What is a certain drug composed of? Its ingredients. We didn't go into that level of nitty-gritty. We just recorded all the TB drugs, not their ingredients, which is why you will also see the ingredients table is also blank. It's empty. Let me show you in the database. So these are our drugs: amoxicillin, cepromycin, kanamycin, all the drugs we are using in the TB, right? Streptomycin, etc. And we have dosage. Is this a combination drug, right? Just that this is a combination. We're not defining what it's composed of. So drug ingredient table is empty. If we had to define the whole composition, you will have to enter this as well. And in fact, I would very highly recommend that you do so. When the migration is complete, it's now very easily doable, because you can just give this list to ChatGPT and ask it to generate their ingredient compositions. It's going to give you the compositions. It's quite easier to do now than earlier. Then maximum daily dosage allowed, minimum dosage we are keeping it null, not using it much. Route, is it taken orally, is it taken through intravascular drug, how is it taken, right? Then there are further, what's the strength in mg, 1000, 250, the drug zone strength, and then dose limit. So this is the unit, milligram, gram. We are not using many of these columns, by the way. The drug structure, it's very lenient in at the moment. So we are just we've defined the drugs, and then that's it, and we create like a regimen from that, from those drugs. So anyway, coming back, that's about drugs. Now there are two different tables which sort of look somewhat confusing. There is an order group, and then there's an order set. How are these two different? By the way, these are also new entries. So order group and order set, although by name they may look same, that they are not same. Order set are like templates. Order set is metadata table. Basically what this does is you have predefined reusable bundles of orders, which is going to help clinicians make multiple orders with a single click. Now, for example, a clinician may say, well, I want to order 3 different type of tests. There's a chest x-ray, I want to order gene expert, I want to order smear microscopy. All 3. In our current system, they will have to create 3 different orders, right? What order set does is that you can create one template, and the clinician will select that single template, and then from that single template 3 different orders would be created, and against those orders, those will be recorded in order groups. The actual data which you combined for one particular patient in a single encounter, that is going to be stored in order groups. So order set is metadata, these are templates, and order group is the real data. As we progress, I believe in the next major revision these have to be part of the next upgrade whenever it is planned, because when you talk about orders make the system overall quite bulky. If everything is one place, this enables you to first of all operationally this is going to make the operation fast, and also generating report, handling, filtering, that also becomes quite handy and easy to do. So this is about orders, and so we are going through the whole schema, by the way, segment by segment. These are all separate divisions of the same OpenMRS schema, and I hope that I'm able to establish foundational understanding. When you explore the data itself, you will get the complete picture. Now next in our list is forms. So what are forms? Forms are like paper forms. They are predefined collection of questions, and for every question we have an answer, an order of questions, and certain validation rules. Mind you, these forms are again metadata. They do not capture the actual data. They only define the template, the fields on a form, on a paper form, in the electronic version of them. So forms have these so-called form itself. Every form has a name, like TB03, or you have TB03U form, right? Form 89. These are different paper forms against which you have created. You can create electronic copies. Now every form has certain fields. Every field has a certain field type, and for every field you may have certain answers, allowed answers. So you can define this whole collection as a single form in multiple tables, and this can be rendered on OpenMRS's UI in different modules, or also fetched from the REST API to populate your own custom forms. However, this was legacy schema. We are no longer using it. In fact, in our last revision, we completely flushed these forms. We got rid of everything. You may still see some data. Let me show you actually. So these are your forms: DOTS form, gene expert result, Hein, form 89. But this is all for legacy purposes. In our current system, none of these fields, this data is being utilized. Form field, field type, you have 4 or 5 field types, so concept, section, etc. The reason is this was all redundant. We already had these rules baked into the UI, so why create a template needlessly? Because we have a custom web application, and every rule, the whole forms, everything is defined over there. There's no need to redefine them in OpenMRS. That's why this was phased out. So which is why this is called legacy. In fact, in the OpenMRS world, hardly anyone is using them anymore. The new programs, that is. The old ones, they may be still carrying on, but the new ones don't. As an alternative, we have this called HTML forms. Now HTML form Forms come from a module called HTML form entry module. Right? This is one flat table, and that flat table contains the whole schema of a whole form. All the fields, the entire form, its rules, its validation rules, its segments, its parts, its ordering, everything is defined within a same HTML form in XML, just like you write HTML, and then that HTML page is rendered on the UI. So all this schema was then replaced by this one single HTML form. Now we have again moved to a dedicated custom web app. We have moved away from HTML forms as well. But if you have a request, say something like you want to collect certain data for one particular program, say some sort of emergency camp for HIV screening, and there's a demand to create a form like in one day, then this is something you might use, HTML form entry module. You can literally create a form in hours, populate it on OpenMRS's interface, and enter data against it. And if you want, I can exhibit examples of it, but we are no longer using HTML forms as well. Now this used to be part of our system, but after migrating to a custom dedicated web application, we have stopped using legacy schema forms as well as the HTML form entry. However, HTML form entry is something which you may make use of in any case of urgent requirements, especially where you don't need to keep a form up and running forever. Like there is sometimes a need to collect certain data in certain places, and for that you need something bespoke. But working with Excel, etc., is not an option. So that's where you use HTML forms, because I will be able to look into it after 4:30 then. So anyways, let me get back to where we were. You can go into OpenMRS's wiki and browse HTML form entry module. This is basically how you represent a form. There's basic HTML, and then there are tags which you can use, and the form that gets populated looks like this. There's very minimum styling, and it's not really built to mimic a real JavaScript frameworks experience like React or Vue or JS or any other tool, but it does the job of data entry, data collection. So if you need something bespoke, here's like an example template. What you can do is, let me just quickly demonstrate. You can simply copy this and go into HTML, manage HTML forms. Let me log in again, and not forms, HTML forms. Where's the HTML form entry module? Yes, we do have it. Interesting. Anyway, yeah, so new HTML form and give it some name, example form version 1, and you can assign it a new encounter, right? Don't use the existing one, just create a new one. So for now I'll just go ahead and pick one because we're not entering anything. As you can see, it already filled a whole template, right? And this template is now rendering as below. So you can choose any location, you can choose a location provider and enter a form. These are the demographic information of a patient you selected, and that's how you can basically collect the data. I will just go ahead and paste. Sorry, this is macros, styles. The part where I need to intervene is, alright, it's a whole complete example. Yeah, so save, and okay, these concepts don't exist. I'll have to these concepts don't exist, so the form won't render, which is understandable. But anyway, the point I was trying to make is this: you can pick a template and add your concepts, add your own custom JavaScript even if you want to, and create a form easily for bespoke purposes. So there's an entire section on the wiki dedicated just to HTML form entry. But this is like, training on this is beyond the scope. This wiki alone is sufficient for to serve the purposes. Nowadays, nobody, no new program would be even considering HTML form entry. You can see the last update, or even over here, was 2021. So this is also it works, it exists, it does its job, but it is not the modern way and is sort of become obsolete. Now is the time, the era of custom web development, since it has become really easy. In earlier days, a decade ago, the frameworks were not really optimized. JavaScript was also in its, you can say, ECMAScript was in infancy. There wasn't high support for HTML5 tags, etc. But nowadays it's quite easy to build interfaces. So this is only for those very special occasions.